Good evening, one and all. Let's wait for a couple of minutes if anyone joins, and post that we will start. Yeah, so should we start? Let me share my screen. Okay, so today basically we will be having the overall brief of the entire course and a few numericals from the previous weeks because like that was done way too back. So that will be a revision for you all. So yeah, can you let me know what was like um can you give the brief of course what we have learned, and you can start briefing all this to me. Yes. Yeah. So would you like to start? Uh, s- yeah, so basically in this course we have been discussing on, sorry, various physico-chemical treatment methods, right, for wastewater treatment. And if you talk about wastewater treatment, then usually it could be like wastewater that is generated from households also that goes ends up into sewage or some industrial wastewater, right? So basically different methodologies or technologies are conventionally or more or less used everywhere in all segments, depending on the actual uh, you know the actual industry or the plant. The technologies might vary a little bit, but more or less they are, the flow is similar, right? So we discussed each of these process in detail, and what pollutants or what are the water characteristics that are required at the end, and what sort of um, changes in water characteristics are observed from different industries, and what are the major composition of water that can cause um, you know difficult, like that could be uh, challenging and require serious attention, right? So can you tell me what are the different types of parameters, uh, just for the revision? Sorry, I got locked out. So let me just give you brief of all what we have discussed so far in maybe 15-20 minutes, and later we will solve a few numericals that might give you the recap or the brief of what we have been discussing so far, right? So firstly, in this course we started off with what all water parameters are there. So water parameters, if we talk about, then it can be divided into uh, physical parameters, chemical parameters, and biological parameters, right? So these come into the category of water parameters. Now, if you talk of these parameters, then physical can be color, odor, then it could be temperature, turbidity. Uh, so in between, I will like to ask you a few questions out of each of these, um, right? So that you can recall all the topics. Turbidity, then it could be suspended solids, right? Then, if we talk about chemical parameters, then it could be hardness, it could be pH, it could be the presence of uh, organics, it could be because of the presence of metals, right? So, if next we talk about biological, then it is mainly because of the microorganisms like bacteria, fungi, viruses, right? So these all are the type of parameters that we might be concerned when we want to have a safe water. So there could be different guidelines, and these guidelines depend, like guidelines for water consumption. So all these parameters, they are checked. Usually there could be more, but they are checked, and depending on the application, these parameters might have some different guidelines. For example, if the end use is for drinking purpose, then it will have some different guidelines. If the end use is for industry, it will have some different guidelines. In industry also, if it is to be used in process, if it is to be used in some boiler, then the specifications of what are required, it all varies depending on the application, right? So it could be for example, agricultural use, if it is to be dumped in surface water bodies, right? So depending on all these uh, applications, the water quality required changes, and that needs to be always, you know, uh, maintained at all times. So you would be knowing that from our households. So what is the source of wastewater? It could be because of the households, it could be from agricultures, it could be from industry, it could be from hospitals, right? So household includes all residential, it could be schools, some office, right? So all sorts of that. So wastewater, or the water that is discarded from all these, they vary, right? So mainly from household, the water that is coming, it ends up into municipal treatment sewage treatment plant. So it is sewage treatment plant, because you know what, from households also you will have wastewater which might have, you will be using this detergent in your house to wash clothes, right? So it will have detergent in it, then it will have soap, wastewater from like the water from toilets, right? So it ends up into sewage treatment, because you need to treat it and again reuse it, right? So that recycling happens. Then industries usually have a way more high concentrations of pollutants as compared to the households, and that is where we require the treatment of the water which is generated, which is not good in quality. And even if you see that water, because like, even if it might not contain some harmful, but sometimes it can be aesthetically also not pleasing. For example, if it just has uh, sort of slight dust in it, then you will not be able to drink it, right? So because of aesthetics, because of its taste, right? So all these parameters, they come into picture when water wastewater is generated. So what are the basic treatment technologies used for wastewater? Sorry, again, I don't know why it is happening. Yeah, sorry, I am getting out of the meeting because of network issue. Please wait here. If I get out of the meeting, I will rejoin every time. Yeah, so can somebody give what are the different, like, so in every industry or in even in municipal sewage treatment plant, usually these many steps are followed for the treatment of wastewater, which includes preliminary treatment, then comes primary treatment, then comes secondary, and lastly it comes tertiary. So will you please someone describe all these, what methods come under these, and I'm sorry. Yeah, so I was talking about preliminary, primary, secondary, and tertiary treatment methodologies. So, can you tell me a few of these methods and describe about it? Yeah, please. So, I will. So, preliminary methods are basically for remove. It includes screens and great chambers. So these are nothing but to remove any bigger coarse particles which are present in wastewater that needs to be removed, and that might be obstacle for you know the further wastewater treatment, that might cause some hurdle or damage to the instruments as well. So that is nothing but preliminary treatment. Now before any uh, process or uh, treatment starts, uh, usually equalization is provided because the wastewater might be generated from multiple processes. Wastewater might be coming from multiple industries in the case of common effluent treatment plant. So you need to have a uniform characteristics of water, a uniform uh, flow rate for the downstream process, because sometimes CETP they struggle with the fluctuations in the flow rate, the fluctuations in the water parameters, right? So in that case, equalization uh, it helps. Equalization helps in maintaining uniform flow rate and avoid shock loads, right? So once you provide equalization, and again one more step might be required, which is neutralization, where you try to adjust the pH of your uh, wastewater so that it is in the range where further processes might happen. So after that, the preliminary primary methods of treatment includes coagulation and flocculation, where you will be providing some coagulants and flocculants for suspended solids to be removed, or basically colloidal particles to be removed. Now these colloidal particles, they are very stable, right? So you uh, destabilize these particles by adding a coagulant, right? So why these are stable? Because they have a certain charge which makes, like, and like charges of particle allow them to repel each other and maintain at a particular distance, so they will not be able to settle on its own, right? So when you add coagulant, you try to neutralize the surface charge of particles, and at the end allow them to come closer by overcoming the repulsive forces, and hence once the aggregates are formed they will be able to settle down, right? So this allows the aggregates of suspended solids to be formed so that settling can happen. So next is sedimentation. So once the uh, coagulation happens, you allow them to settle in a sedimentation tank, and it could have multiple geometries: circular sedimentation tank, horizontal, sorry, vertical, and so on. So where you are allowing, like you provide gentle mixing and you allow the suspended solids which have aggregated to settle down, right? So it allows the settling. So once this suspended solids have been removed, it goes for the removal of organics, where you provide secondary treatment by, which is also known as biological treatment. So here you provide microbes, usually bacteria, right? So microbes, they oxidize, like the organics will be food for them. So this is applicable only for the biodegradable organics, okay? So microbes, they oxidize the organics. So what is BOD and COD in this regard? Yes, anyone? Can you tell me what is BOD, COD with respect to water parameters? Okay, so BOD and COD is nothing but BOD refers to the biological oxygen demand and COD refers to chemical oxygen demand. So for uh, so biological oxygen demand is nothing but the amount of oxygen required by the microbes to oxidize the organics which are present in wastewater, right? And COD represents the amount of oxygen required by the chemical for the complete oxidation, right? So when your organic content is more of biodegradable, BOD and COD might or will almost be equivalent. But when you have more non-biodegradable chemicals or organics, then your COD will be higher as compared to BOD. Okay. So if you have higher COD and low BOD, in that case biological treatment might not work, where you will require tertiary advanced oxidation processes, which are nothing but the oxidation of non-biodegradable organics including pharmaceuticals, dyes, pesticides, insecticides, and so on, right? So some petrochemical petroleum products as well, these all generate heavy or high concentrations of organics which are non-biodegradable. So in that case you might require advanced oxidation processes as well, which might be, you can say, Finton, where you are using Fe2 plus and H2O2 for the generation of oxygen radical, OH radical, right? Then you can use photocatalysis. You can also use ozonolysis. So there are multiple processes, but depending on the industry, they might or might not be applicable, or advanced oxidation still is requiring more attention for the actual industrial application. Next is, if you want to remove any specific pollutants, then there are different methods which we had talked about, including adsorption, where you can adsorb a few pollutants including heavy metals. Then you can adsorb organics on a surface. So adsorption is basically interaction of the pollutant which is adsorbate with the adsorbent, and because of the forces they sit on the adsorbent surface, which causes the removal of the pollutant, right? So from wastewater it ends up into onto the surface of wastewater. So can you brief on what are the steps of the adsorption process, like what is the travel path for for adsorbent from adsorbate, sorry, from the bulk of wastewater to the surface of wastewater? So I guess I shouldn't directly discuss, the numericals because of the network issue. We will directly discuss that because that is more important. So yeah, determining the concentration of suspended solids, right? So um, a filterable residue analysis is run on a sample of water as follows. Prior to filtering, the crucible and filter pad are kept overnight in the drying oven and cooled, and the dry mass of the pair determined to be 54.352 grams. Now 250 milliliter of water sample is drawn through a filter pad containing contained in the porous bottom crucible. The crucible and the filter pad are then placed in a drying oven at 104 degrees Celsius. So 104 degrees Celsius ensures that all the water will be evaporated, right, and dried until a constant mass of this much, right. So determine the suspended solid concentration of the sample. So when you want to determine the suspended solid amount, the best way to do is you evaporate uh, all the water out of it and you measure the solid content, right. So whatever will be the left weight, that will correspond to the suspended solids, but for that you might require some uh, beaker filter, right. So here you need to pre-weigh it so that you will be able to subtract the mass of filter or crucible in which you are doing that. So already you are given a crucible and filter pad weight which is 54.352. Now crucible, okay, crucible plus the suspended solid will be, because now you have evaporated all the water and whatever will be left, that will contain suspended solids also, right. So no water weight will be there, it will be only crucible plus filter pad and including the suspended solids, which will be 386 389, right. So when you want to find the weight of suspended solids, just subtract the crucible and filter weight, which is 54.389 minus 54.352, right. So that should be your answer. You can calculate it by yourself. Okay. Next question is, express the following concentrations of the compounds um, as milligram per liter of calcium carbonate. So first question before starting this, why do we express the concentrations of, like, for hardness mainly in terms of calcium carbonate? So the reason behind this is it is easier to express in terms of calcium carbonate because it has 100 molecular weight gram per mole, which is easier to normalize, and you will not be able to you won't be able to consider multiple ions, so all will be accounted when you convert into calcium carbonate. So let's first start solving the question. How will you do that? So MgSO4 concentration given to you is 420 mg per liter. So always you need to have a unit check before you solve, and for calcium bicarbonate it is 221 milligram per liter. So when you want to convert it into milligrams per liter of calcium carbonate, first you need to do the conversion into milli equivalents per liter, then and then only you will be able to convert it, right. So because each of these might have different molecular weight, different valency, and hence it will be easier for expression in milli equivalents per liter. So let's calculate the equivalent weight of each. Equivalent weight of MgSO4 will be, let's and the molecular weight, right. So first calculate the molecular weight, from that you will be able to calculate the equivalent weight. So molecular weight of MgSO4 will be 24 plus 32 plus 4 into uh, 16, that will be 64, right. So it should be 120. Now 120 will be the molecular weight divided by valency or number of, right. So valency here, which is 2, so 120 by 2 is 60 milli equivalents, right. So 60 is the equivalent weight, equivalent per mole. While if you talk about calcium bicarbonate, so it will be calcium is 40, then hydrogen is 2, carbon 12 into 2 plus oxygen 16 into 6. So its weight is, molecular weight is 162, right? So what will be the equivalent weight of calcium bicarbonate? So since here the overall valency for calcium is 2 divided by 2, so equivalent weight will be 162 by 2, which is 81 is the equivalent weight. Now convert these concentrations in terms of milli equivalent per liter. So milli equivalent per liter of MgSO4 will be 420 by 60, and for calcium bicarbonate it will be 221 by 81. Okay, so solve this. So that it should be 7 milli equivalent per liter, and this should be 2.72, okay, milli equivalent per liter. Now to convert it into calcium carbonate, you need to multiply it with the equivalent weight of calcium carbonate, which is 50. Okay, so first you add this, so total hardness will be 7 plus 2.72, which will be 9.72, and in terms of calcium carbonate, so it should be 9.72 into 50, that will be in milli equivalents per liter, right? So 9.72 cross 50, which is 486 milli equivalent per liter. Now if you want to convert it into, okay, I'm writing here, so 486 milli equivalent per liter as CaCO3. Now if you want to convert it into milligram per liter, multiply with the valency itself. Okay, so which is 486 into 2, which means it should be 972 milligram per liter. Am I correct? Let's move forward. Then next question. Which of the following salts are the main causes of temporary hardness? So temporary hardness and permanent hardness, right? So these are, hardness can be divided into two: temporary and permanent. So temporary is because of the carbonates and bicarbonates, because this can be removed by boiling the water, and these are rest all, right? So including uh, chlorides, nitrates, okay, sulfates, yeah. So which is temporary hardness in this case? So it should be carbonate hardness, right? So magnesium carbonate. Next question. In a BOD determination, 6 ml of wastewater is mixed with 294 of diluted water containing 9.1 milligrams per liter of dissolved oxygen. After 5 days of incubation at 20 degrees Celsius, the dissolved oxygen content in mixture is 2.8. So BOD of wastewater is dash. Assume initial dissolved oxygen of wastewater is 0. So you need to find BOD. So BOD is nothing but the oxygen required for the degradation of organics, right? So here, if initial BOD dissolved, sorry, DOI is 9.1 milligram per liter, and finally it is remaining as 2.8 milligram per liter. So whatever will be the consumed dissolved oxygen, that is because of the organic content of wastewater. Now it is only 6 ml of wastewater, rest is DI water, so it is basically diluted. So the oxygen demand here actually is 2.8, but you need to consider the dilution factor, right? So total hit here it is 300 ml produced, and you have only added 6 6 ml of wastewater, right? So this is nothing but known as dilution factor. So it means that how much times you have diluted the water, right? So it is nothing but what is the final volume of water divided by wastewater volume, right? So here it will be 300 divided by 6, correct? So the concentration will be, or BOD you can say, will be 9.1 minus 2.8 into 300 divided by 6, which is 315 milligrams per liter of BOD is present. Is it clear so far? Sorry, I'm having a lot of network issue today. I don't know why my Wi-Fi is disconnected. So, next question. Do you have any doubts so far? Like, are you able to hear me, or I am logging out of the meeting very frequently? So if I'm logging out very frequently, what we can do, I will write down the solution of numericals for, and I will post the slides, and you can look into it. And for now, if you have any doubts, you can let me know. So, or should I continue here only? Okay, let's continue. A dechlorinated secondary effluent is placed in a storage basin until needed for reuse. If the initial DO concentration is 1.5 milligrams per liter, estimate the time required for the dissolved oxygen concentration to increase to 8.5 milligrams per liter due to aeration. So you are providing basically the aeration to water so that the DO concentration increases from 1.5 to 8.5. Mm, Sorry for this question. I guess I am missing out the table which needs to be provided. So I will, what will I will do? I will write down the table. I will write down each and every step of this question. Yes, see, I'm missing out the table. So I will mention this and post the solution for this question, right? So for that, I'm sorry, I will post the solution for it. And I guess the last question, a water treatment plant treating 50 into 10 to the power 6 liters per day, which is 50 mld million liters per day of water requires 20 milligrams per liter of alum. If water has 6 milligrams of per liter of alkalinity, determine the quantity of alum required per day and year. So basically you just need to find out what will be the amount of alum required per day and per year. Now alum concentration is already given to you, right? And you just need you know what is the amount of volume of water also treated per day, which is given you as V equals to 50, like basically Q equals to 15 to 10 to the power 6 liters will be treated in one day. And for that the alum concentration maintained is equals to 20 milligrams per liter. Okay, so per liter you require 20 milligrams of alum, right? Which means 20 milligram alum required per 1 liter of wastewater treated, right? So now you need to find out in one day what is the amount of wastewater treated. One day water treated is 50 into 10 to the power 6, right? Because it is 50 into 10 to the power 6 liters treated in one day. Okay. So multiplied alum required per day will be 50 into 10 to the power 6 into 20, right? So that will be in milligrams. So 5 twos are, it is 10. 10 into 10 to the power 8, which means it is 10 into like 10 to the power 9 milligrams, right? So you can convert it into kg, right? By dividing it by, maybe you require 1000 kg, and for 1 year you multiply, like the volume treated will be 50 into 10 to the power 6 into how many days in a year? 365, right? So this much will be the volume treated, and now you multiply this with 20 into 50 into 10 to the power 6 into 365, which will be the amount of alum required in milligrams. You can convert into some other units with depending on the question, or if it is asked for. Otherwise you milligram is a very small unit, you can convert it into kg or ton, right? So 1 milligram. Okay, I will provide you with the conversion as well in the next slide, maybe. Yeah, so the conversion is 1000. Okay, so uh, 1 kg is equals to 10 to the power minus 3 ton. That is equals to 1000 grams. That is equals to 10 to the power 6 milligrams, right? So this is the conversion of kg into tons and milligrams and grams. So you can enter convert also depending on the requirement, what is asked in the question. And you cannot obviously write 10 to the power 12 milligrams if it is required, right? So it is better to convert it into some kg or tons, because it is easier to understand and easier to interpret, right? So I will post the answer for the question which we have missed. uh, yeah, so other than that, do you have any doubt till this point, or for entire course which we have covered so far, because this will be the last live session. And uh, yeah, so if you have any doubts, you can come up with your doubts. I will be here for around 15-20 more minutes. You can look for your doubts and do let me know. Yeah, otherwise this is it from my side. I hope you learned a good content with this course, and this course will be helpful to you in some means, wherever, like, to whatever field you are in. So I hope you enjoyed the course. And yeah, thank you everyone for joining all the sessions. You can come up with your doubts if you have any, right? Thank you everyone. Okay, so do you have any more doubts? Else, we can end this meeting for today. Okay, so I assume there are no more doubts. Thank you everyone for joining. I hope this course was insightful to you all and it will help you in whatever in all your fields, and you will be able to apply this course in your fields. Thank you everyone for attending this course. Thank you everyone for joining all the live sessions. Thank you.